right, so we're going to review a little bit or do a little bit of new stuff with polynomials, some more simple things, things that you probably have used before or seen before to start off. And so what is a polynomial? Well, a polynomial is when I add or subtract lots of monomials. Well, I haven't really told you what a monomial is yet. But basically, a polynomial is like 2x squared plus 3x minus 7x to the fourth, something like that. Just have a lot of numbers and variables added and subtracted. There's something called the degree. The highest exponent of a polynomial is the degree. So if we look at all of the exponents across our polynomial, whatever the largest one is, I might say the degree is 4. Or I might say the degree is 2. Whatever that largest exponent is. Something else we call the leading coefficient. And this is the number in front of the variable with the highest exponent. So if my highest exponent is 4, I have an x to the fourth. Whatever number is in front of that is my leading coefficient. So if it's 2x to the fourth, my leading coefficient is 2. And usually we want to write our polynomials in standard form. So where the exponents go biggest to smallest. That's called descending order. They get smaller. So if I have an x to the fourth, that's listed first, and then x cubed, and then x to the second, and then just x, and then just my number. So usually your leading coefficient is the number in the very front. But if your polynomial is not written in the correct order, it may not necessarily be in the very front. And so we name polynomials based on their degree and based on their number of terms. So let's look at this chart here on the left. If the degree is 0, meaning there's not an x at all, it's just a number, that is called your constant. So there's not even an x. Like if it's just the number 7, that's just a constant. If the degree is 1, meaning we just have x, like x to the first, so like 2x, 5x, that is linear. It makes a line. If the degree is 2, so the highest exponent is x squared. Now we could have an x squared and an x, but I'm looking at the biggest exponent. If it's 2, that's a quadratic. We just spent a whole unit on these quadratics. Every one of them, the highest exponent was a 2. If it's 3, we say it's a cubic. So if we have x cubed plus x squared plus x plus 2, that's a cubic. If we have a degree of 4, this is quartic. And a degree of 5 is quintic.
Matt Brown, call 2647, Matt Brown.
Now a term is like if I look right here at number 2, each one of these is a separate term. Like if I have a plus or minus in between them, that separates the terms. So term, term, term. So if we just have one term, so there's really nothing added or subtracted, this is a monomial. Two terms is a binomial. Any guesses on what 3 terms might be? Trinomial. Now, after 3, they just kind of quit. There might be actual names for 4, 5, and 6, but most of the time we don't use special names. From here on out, we just get generic. We say it's a polynomial with blank number of terms. So if it's got 4 or more, you just say a polynomial with 7 terms or something generic. So let's go through some examples of naming these polynomials. So number 1, what is the degree? What is the highest exponent? Do you even see an exponent? No, but we do have an x. And what do we assume the exponent is when there's just an x? 1. So this is really x to the first. So the highest exponent that I have is 1. What is my leading coefficient? What's the number in front of my x to the first? -3. The leading coefficient is -3. That has nothing to do with naming the polynomial, but sometimes you may be asked what the leading coefficient is. So most of the time it's just the number in the very, very front. How many terms do we have? 2. This one is a term, and then there's an addition sign, so that separates the terms. That's another term. So we have 2 terms. So if the degree is 1, it is a linear, in 2 terms, binomial. What's my leading coefficient on number 2? 9. What is the degree? 5. Notice the largest exponent is 5. I have an exponent of 5, an exponent of 4, and an exponent of 1. So the biggest one is 5. So the degree is 5. How many terms does it have? 3. 1, 2, 3. So each time there's an addition or subtraction here in the middle, that separates a term. So I have 1, 2, 3. So a degree of 5 is a quintic. 3 terms, trinomial. What's the degree on number 3? It's 0. There's not even an x at all. So that makes the degree 0. And is there anything being added or subtracted to this 24? No. So it's just 1 term. So a constant monomial. Number 4, what is the degree? 3. That's the biggest exponent. What's my leading coefficient? 1/2. And then I've got 1, 2, 3, 4 terms. So a degree of 3 is a cubic. And then 4 terms, I'm just going to say polynomial, and you can abbreviate that with 4 terms. Occasionally, you might just see it as cubic polynomial. It might not actually say, though, with 4 terms, but that would be your answer. I want you to try numbers 5 and 6. All right, number 5, you should have gotten quadratic trinomial. What's the leading coefficient on number 5?
-1.
-1. Number 6, it's a quartic monomial. Notice, there was a minus in front of it, but there's nothing being added or subtracted, so there's really only one term. What's the leading coefficient on number 6? -3/2, -3/2. Okay. All right, number 7 and 8, I want you to write an example. Number 7 is a cubic binomial, and number 8, linear monomial. So come up with your own example. There are many, many possible answers. So number 7, it's a cubic, so your largest exponent should be 3. And you could have a number in front of it. So -7 x cubed. And it's a binomial, so we need to add or subtract something else. So you could add 2x squared. You could add 2x. You could just add 2. But you cannot add another x cubed or anything with a higher exponent than 3. So you could have had 5x cubed minus 12 or something. But your exponent needs to be a 3, your largest one, and then something smaller possibly. And a linear monomial. Basically, you can only have an x. It could have a number in front of it. So like 20x or -2x or just plain x. But you can't have anything added or subtracted because it's a monomial. Any questions so far? All right. So let's turn the page. And we're specifically going to talk about monomials for a little bit and talk about exponent rules, which you probably have seen before, you've probably done before, but you may not really remember all of them. So just for example, a monomial could be like 2x. We could also have several variables like 3x squared, y to the 5th, z. That's a monomial. You can have as many variables as you want with whatever exponents as long as nothing is added or subtracted to that. It's just like one big chunk of them. That's a monomial. And we're going to talk about the rules for exponents, specifically kind of with some monomials here. So number 1, the product rule. So if I have x, all right, so if I have x to some power, you can go on if you want, times x to the b power. I'm just x to the some power times x to another power. What do we do with those exponents? You add them. If you are multiplying variables, you actually add the exponents. So if I do an example of that, that would be like x to the 6th times x squared would be x to the what? Nope. Eighth. X to the 6th times x squared is x to the 8th because you add the exponents. The power rule says if I have x to some power and I have another exponent, I raise that to a power. So we have an exponent within an exponent. What do I do with the exponents? Multiply them. This will be x to the a times b. So for example, if I have x to the 6th and then I square that, then it's x to the 12th. Good. if we have x to the a divided by x to the b, you subtract them. X to the a minus b. So x to the 6th divided by x squared would be x to the 4th. Subtract. 6 minus 2 is 4. Now there's a rule that says you can't actually have negative exponents. So if I have x to the negative a power, you got to fix that. You can't leave it as a negative. What we do is we make it a fraction, and that x goes to the bottom of the fraction, and your a becomes positive, and it gets a 1 over top of it. If it can be simplified, sometimes there's more simplifying you can do, but most of the time it stays like that. So if I have x to the negative 2nd power, that's really 1 over x squared. I'm gonna give you an example with just straight numbers in just a minute to show you why that is, and same thing for the next rule. And the 0 exponent rule says x to the 0 power, anything to the 0 power, does anybody know? It is not 0. It's 1. I'm going to show you why. So even if I have like 3x to the 0 power, as long as that's in parentheses, the whole thing, that's equal to 1. So let's go over here, and I'm going to explain those two rules because those kind of seem like they don't make sense. So what if I have 3 to the 4th power? Somebody type that into your calculator and tell me what 3 to the 4th power is. 81. What's 3 to the 3rd power? 27. Okay. 3 squared, 9. 3 to the 1st power, 3. So as my exponents are going down by 1, what is happening to these numbers over here? Specifically how? What's happening to them? They are a lot. They are getting divided by 3. So that pattern continues. So if I have 3 to the 0 power, what's 3 divided by 3? 1, not 0. And then if I keep it going, what's 1? Well, 1 divided by 3 is 1/3, right? 1, it's really 1 over 3 to the 1st power. And then if I keep it going, type in 3 to the no. Don't type in 3 to the negative second. If you take 1/3 and you divide that by 3, we're continuing the pattern. So type in 1/3 divided by 3. You get 1/9, right? Which is really 1 over 3 to the 2nd power. And if we were to do it again, we would get 1 over 27. And then 1 over 81, and so on. So that's kind of where those rules come in, these last two that are kind of new to you. If you look at real numbers, there's a pattern that causes those rules to be there. So we're going to do some examples. We're just going to finish this page today. So number 9, we are multiplying. Now those rules that we just wrote down, those are specifically for exponents. Are these 5 and -7, are those exponents? No, so you just multiply those like normal. So what's 5 times negative 7? Negative 35. And then for our variables, what do I do with the exponents? You add them. This would be x to the 8th. So I want you to get in the habit of checking your answer. Something you can do is store any number for x. It don't matter. I wouldn't pick a big number because like 5. 5 store x. And if I type in 5x squared times negative 7, x to the 6th, and then I type in negative 35, x to the 8th, those numbers should match. If they match, you did it correctly. Number 10. So we have this monomial and we're squaring everything. So what is negative 2 squared? You did not. You should put the negative 2 in parentheses. Remember that. If you do negative 2 in parentheses squared, you get positive 4. Then if I take x cubed and I square that, what do you do with the exponents? Multiply them. So I would have x to the 6th, and then y to the 2nd. Yep. So if we want to check negative 2, well, so we have two variables, so I need to store a number for y. So let's just do 3. Store, and then I'm going to get my y. And I already had that x stored. I can just leave it. So negative 2x cubed y, and that's all to the 2nd power. And then I'm going to test 4x to the 6th y squared. And you see how they match? That means you did it right. Doesn't really matter what that number is because you could store anything. But as long as they match, you have a correct answer. Now these, when we're dividing and we have fractions, there's a few ways you can think about them, and it's easy to mess up. So I kind of want you to pay attention to what I'm doing here. If you have a fraction bar, go ahead and get a fraction ready for your answer. Sometimes you may not end up with anything on the bottom, and you could kind of drop the fraction bar. But sometimes you will, so it's good to go ahead and have it. So 54 divided by 8. You're not going to get a whole number. So if I just go in and type in 54 over 8 as a fraction, it'll simplify it for me. Or you could have done 54 divided by 8 and then converted that to a fraction. Whatever. But it simplifies to 27 over 4. Now, on questions like these, I really don't like to use the quotient rule. I don't want you to think of subtracting them. But look at your x's. I have 6 in the top and 2 in the bottom. So something like this. I have 6, 1, 2, 3, 4, 5, 6 in the top and 2 in the bottom. We want to cancel out as many as we can. So if I cancel out those, I cancel out those. What am I left with? 4 in the top or in the bottom? The top. So I have x to the 4th left in the top. And then what about the y's? So I have 4 y's in the top and 1 in the bottom. If I cancel 1, I'm left with what? Y to the 3rd in the top or in the bottom? The top. Yep. And so we have 27x to the 4th y cubed over 4. Questions like these, a lot of people, especially if I were to divide those and it comes out evenly, a lot of people write that number out front and then always write their variables beside of that. But that's not always going to give you the correct answer. So I would always make sure you just start with the fraction bar and put everything either in the top or in the bottom. Otherwise, it's going to get a little messed up. Okay. Number 12, we're multiplying. So what's 2 times 10? 20. Then I have x. I have 4, x to the 4th times x to the negative 7th. What do I do with those exponents? You add them. So what's 4 plus negative 7? Negative 3. You cannot leave your answer like this. So what did I tell you that you did when you had a negative exponent? Right, you put it on the bottom, but be careful. The 20 does not have that exponent. It's only the x. So only the x moves to the bottom. So 20 over x, and then it becomes a positive 3. So only the part that has that negative exponent gets to move. Questions? All right, number 13, we kind of have two things. So we're only going to do one part at a time. So let's do this part first. Exponents come first. So what is 5 squared? 25. Yep. Then x to the second, when I square that, now we multiply your exponents. So I would have x to the 4th and y to the 14th. Good. So numbers out front are not exponents. They just get squared like normal, and then your exponents you multiply. And so we have times 6x cubed y. What's 25 times 6? 150. What's x to the 4th times x cubed? X. Well, you multiply these, but it's x to the 7th. X to the 4th times x cubed is x to the 7th. What is y to the 14th times y? Be careful, don't say just 15. Y to the 15th power. It's not just 15. The exponent is 15. But be careful. So one like this that had multiple steps, this would be a good one to check your answer. Okay. Number 14, I've got this negative 5x to the 6th outside. So what are we going to do on this one? We're going to use the distributive property. We got to multiply. Negative 5x to the 6th times 2x. What is that? Close. Negative 10x to the 7th. We have x to the 6th and then another x makes x to the 7th. What's negative 5x to the 6th times 6xy? Negative 30. X to the 7th. Just y. Because when those are different variables, you don't add those exponents. So it's just y. And then negative 5x to the 6th times negative 8x squared is what? Plus 40x to the 8th. Perfect. All right, number 15. I see a fraction, so I'm just going to go ahead and know I'm going to make a fraction bar. What does 15 over 24 simplify to? 5 over 8. Now, my x is, what is x to the 0?
1.
That's just 1. And I don't have any x's on the bottom, so that was all I had. And then the y's, that's not x to the first power. It's just 1. Just the number 1. And then the y's. I have 4 y's on top, 7 y's on bottom.
You have 3 y's on bottom.
When I cancel out, I'm left with y to the third on the bottom. And so this, what's 5 times 1? 5. So it's just 5 over 8y cubed. All right, now this last thing, if I have a fraction with an exponent outside, that's the same thing as doing 2 to the 4th over x squared to the 4th. You basically raise the numerator and the denominator to that exponent. And what is 2 to the 4th power? Nope. Yep, 16. And what is x squared to the 4th power? X to the 8th. Not just 8, x to the 8th power. Because if you put an 8 there, that's going to be 16 over 8, which is 2, which is not right. All right, so we're going to stop there today, and we'll practice some of this tomorrow.